Hi, everyone. Thanks for coming to the third in our series of webinars about SensorThings, our introductory Getting Started series. This is going to be about a RESTful pattern for IoT API, so a RESTful pattern for Internet of Things API. Basically, we're going to be talking about connection. It's going to be presented again by Dr. Steve Liang, a professor of geomatics engineering at the University of Calgary. Steve's been working in IoT and sensor web for over a decade. He's an expert in the field, and he is the SensorThings author as well as the SensorUp founder. So you're going to be getting a presentation from somebody who knows his stuff. If during the presentation you have any questions, we'd absolutely love to have them. Just move your cursor to the bottom of the meeting screen for the Q&A panel, and we'll answer the questions that come up after the presentation. So I think that covers everything we need for now. So I'm going to hand it off to Steve. And once again, thanks, guys. Happy to have you.
Hello, everyone. Great to see you back. And it's just great to see we have participants from all around the world. And I'll make sure today's webinar is worth your time. Okay, so today we'll talk about the RESTful pattern. So today will be more technical, but hopefully it's easy to follow. Okay, agenda. So recap, we will go through the SensorThings data model first, and then we introduced last week. And if you want to review, you can go to the YouTube channel of SensorUp, and you can get watch the video again. And we'll introduce IoT RESTful pattern and show you many examples. So it's about me. This is for some, you know me, a lot of you, but I'm a professor, I'm a researcher, and I'm also an entrepreneur. I'm an editor of the SensorThings API. And this is about SensorUp. SensorUp is a world leader in OGC, sensor web, and Internet of Things. We're leading several international IoT standards, including OGC and ITUT. And we developed the world's first OGC SensorThings API implementation. We are a proud member of Eclipse Foundation and OGC, Open Geospatial Consortium. Okay, so let's dive into this. So data model. On your screen, you can see 8 boxes, the UML diagram. So each box is an entity of the SensorThings. So from the bottom left, you have your thing, and a thing has location and historical location. For the things that moves, it has historical locations. And a thing can have 1 to many or 0 to many data streams. Think about a thermostat. And thermostat has a temperature sensor and humidity sensor. So it has at least 2 data streams, 1 for temperature and 1 for humidity. And each data stream use a sensor to collect the data. So that gives you the contextual information about what's produce this data stream. And each data stream is also described by observed property, so which is the phenomenon this data stream is observing. For example, the room temperature, air temperature is the observed property. And on your right-hand side, the main focus of this API is observations. So these are the readings collected by the sensors that observed certain observed property. And for each observation, it has a feature of interest. For example, I have my thermostat at home, and the feature of interest of the observation will be my home is the feature of interest. So this is a very quick recap of the data model. And today, we're going to talk about how do we use SensorThings API to access each entity and filter each entity. Okay, prerequisites. That's a professor in me talking. So I assume you have the basic knowledge of REST. And if not, there's a link for you to read more about REST. And basic knowledge of JSON. And JSON right now is the current encoding for SensorThings API. For many reasons, it's web developer friendly, it's efficient. But in the future, we might have different encodings. So that's a great thing about following an open standard and having a conceptual model, because in the future, who knows, in the next 5 or 10 years, what will be the next encoding, right? But we're based on this ONM, observation measurement data model, and right now we use JSON encoding. In the future, we still keep this extensibility to change to something else. Before we start, I want to share these things with you. First, SensorThings API is all about links. So you will see a lot of links. And actually, this is how the web works. This is how we design this API, is about links. So this design principle gives you great discoverability. So great for search engine, great for catalog. If you have 1 million things, it's very important to let your user to find the things you have in this API, right? So great discoverability. It's great for dynamic use cases. It's very efficient and offer you great developer experiences. We'll show you that later, and hopefully you are convinced. And it's very big data analytics friendly. Because with the links, you can outsource. It's easy to integrate with other big data analytics platforms like Spark, Stream, Lambda architecture, for example. And these topics will be covered in the future. And so first, it's all about links. Secondly, SensorThings API give you a uniform and consistent pattern to filter, to query each entity. So if you look at other APIs, many of other APIs, actually for each data model, like entity, they have different query or filter functions. And in SensorThings API, we provide you a uniform and consistent pattern for every entity. So in this case, it's really, really developer friendly, and you don't need to, you learn once and apply to all the entities. So that's a great thing. So that's before we start, just to let you know this. Okay, so let's dive into the details. For every entity, we have a common control information. I'm going to show you a detail later, but the following three are the common control information. That means for each entity, it has the following three attributes. The first one is ID. I think you know why do we need an ID. So ID allow us to uniquely identify the entity. The second is the self-link. That's the URL linking to that entity. So in this case, it's easy for you to index and to link back to this entity. And navigation link. And the third one is navigation link. It allows you to link to the related entities of this entity. For example, the thin has 0 to many data streams. So when you look at the thin entity, it has a navigation link, allow you to link to the 0 to many data streams. Let me show you example. So this is a thin entity example. So the red box, the first one is the ID. So in this case, ID is 1. And actually, the type of ID can be any. So it could be a UUID, it could be a string, it could be an integer or double, whatever. The second box, self-link. So that is the link. So link allow you to link to this thin. So URL/things number 1. And navigation link. So you look at it, it's the third box, locations at IoT.navigationLink. So that tells you that the following link, the right-hand side of the box, allow you to link to the related locations. And we have 3 different navigation links in this case. So allow you to link to locations, to data streams, and historical locations. So let me show you an example. Hopefully you can see the screen. I'll make it bigger. So let's say we have the things here. So click the things, and then allow you to link to here. So here you have the self-link. So this link allow you to link to this particular entity. So in this case, this is linked to this particular entity. And this is the ID. And then these are the navigation links here. So by clicking this here, this link allow you to connect to the related data streams. So if I click on it, it doesn't have data streams. Yeah, but a good idea. You click on it, and you can link to the data stream. Let me find you a particular thing. Okay. So in this case, for example, this is a Linky1 sensor and then you can get to for example, you click on this link, it links you to the related data streams. Click on this, link you to the historical locations. Okay, let's go back to the slides. After the common control information, let's dive into the URL patterns. there are 7 different patterns. First one is the root. So root URI. So we have the root, the service root URI, and then there's a version number, version 1.0. And after that, there's a resource path, so allow you to link to certain entity set. And after the resource path, you can put a question mark and put your query options over there. If you go to a root URL for every SensorThings API, this is what it shows. It shows the entities, so the 8 entities, the data models, and the links to each entity set. After the root, you can link to an entity set. For example, you can link to all the things in this API or all the observed properties in this API. So the red box shows that before that red box, that's the URL path. And then after that, that's the resource path. So observed properties. In this case, it links to all the observed properties in this SensorThings API. And so the blue box shows the first observed property, and the second box, the green box, shows the second observed property, and so on and so forth. So this links to a entity set. This is very common. Actually, it's a common practice in all the RESTful APIs. So after you can link to a set of the entity, so for example, all the things. And right now, the number 3 convention shows you how to link to an individual, a particular entity of your interest. So in this case, look at the red box here. That's 1. So it linked to the thing number 1, ID number 1. So I1 in this case is the ID. So include within the parentheses. Okay. So let me show you an example first. Maybe it's easier. Here. Okay. So in this case, for example, here, look at URL. So I show everything. In this case, if you look at here, in this sandbox, we have 782 things. And let me link to the thing of my interest. So that thing has an ID of 453605. So it links to that particular thing. Okay, so that's the URL path, URL patterns. So after you link to a particular entity, and what if you want to know the property of an entity? So that's very easy, / the property name. So in this case is, if you want to know the result time of a certain observation, so / result time, and return a JSON object of that property. So let's go to the example here. There's in this case, let's say I only want to get the description of this thing. So / description, you get the JSON object back. But in some cases, you don't want even deal with JSON. You only want to know the value of that description. So in here, you put it here, /$ value. You get you the value of this description. So as you can see, this is very, very efficient. Okay, so I cover the value here. I just show you an example. Okay, this one is very, very important. After you learn this one, level up. It's very, very powerful. It's addressed to a navigation property. So let's look at this example. So from data stream number 1, you / to a related entity. In this case, is a observations. It will return all the observations in the data stream that holds ID number 1. That means it shows all the observations of this particular data stream. So this is very powerful because in SensorThings, it's not a hierarchical design. It's a cross-linking. So let me show you an example here. So let's say I want to know for this, I want to know the data streams of this thing. So let me click data streams. So it returns, in this case, returns 5 data streams. But I also want to know, let's say, I don't want to stop here. I want to know more. So I want to link deeper. So I want to know the data streams. And For example, I want to know this particular data stream. So I use the ID here. So I link to this particular data stream. And I want to know the observations of this data stream. So you allow you to link to observations. So in this case, by reading the URL, actually, this is like a query. This URL tells you these observations are from data stream 453610 and from thin 456305, for example. And I can keep linking forward. Let's say I want to know the feature of interest of this particular observation and feature of interest. So you just keep linking. So this is very, very developer friendly. As you can see, if you are developing a client application, it allows you to navigate among these different entities. This is very important. And this is a very intuitive query mechanism. Okay, next one. Association link. So in the links here, let's take a look at this example. From these observations, I want to know the feature of interest of this observation. But sometimes I only want to know the link to this entity. So I can get just the link. So this is very search engine friendly, or if you are developing something for search, for discover the entities in your API, and this is very search engine friendly and very, very efficient. You don't need those unnecessary information. Okay. Next one, nested resource path. Actually, I kind of covered this. I just show you an example, right? You can keep linking from one entity to the second entity and to the third entity. So you can just go like on and on and on. And it is like a query. So I show you this. It's very powerful. Okay, so basically these 8 different URL patterns can be applied to every entity in SensorThings API. So no matter which entity is a thin, a data stream, or observed property, it applies. So it's a consistent pattern. Once you can access the entity of your interest, and you might want to do some query to filter. So we support a set of very powerful query options. So these are some of them, the important ones. So how to do query? So as you can see, actually the design is we have very careful design. For example, we have server-driven paging. I will talk about what's server-driven paging. And the following 4 filters, they are before you apply any server-driven paging. And the following 2 filter, the options, and it's applied after the server-driven paging. So the first one, expand. This is very flexible. It's very, very powerful. So the expand system query option indicates the related entities and to be represented in line. So what does that mean? Let me show you example. The best way is to do example. As say I have this particular observations. Okay, so let's take a look. So this is observation, and it tells me the result. And tells me the phenomenon time. Okay, so let's say, but this return only give me the information about these observations. But however, I'm writing a mobile app, and I want to know what is the data stream. I want to know what is the observed phenomenon, observed property of this observation. So I can use expand and data string. So this will change this. This right now is a link. This will change this into a inline representation. So let me execute this query. So this used to be a link, but right now it's inline. So you can get the information from this data stream and with one request. So if you're writing a client application, it really saves you a lot of time. With more example, you can expand multiple level. So the previous example, we show you just one level, but this example, I'm just gonna show you, you can have expand multiple level. For example, let's say we have thin. Let's say we have this thin, and I want to expand data streams as well as the observed property. So, but let me show you the first level first. So this expand the first level, data streams, and the observed property in here is still a link. So it's not inline, but let me do this expand. So with one request, you get your data stream back as well as observed property back. So as you can see, this is very, very flexible if you're writing a client application or analytics. Okay. And you can expand multiple as well of the same level in this case. For example, I want to expand data stream in this case, as well as the, say, location. So data stream is inline, and locations, sorry. Data stream inline, locations inline as well. Okay. This is very, very powerful. You will love it. Okay, select. Some of you might be wondering, it is kind of verbose, right? A lot of JSON get returned. But select allow you to only return the entities or the properties of your interest. It's great for performance, reduce response time, and data size. So let me show you an example. Let's say I have this particular thing. And right now, I am only interested in the description. So I can do select description. So only return me the description. But let's say I also want to have ID. So description and ID. Let's say I also want to, for example, this call give you return all the observations in this server. So it's about 700,000. And then let's say I only want to know the result and phenomenon time. So as you can see, this is very, very super compact return. So save you, give you great performance and save you the data transmission. Next one. The other design allow you to have a greater performance is a result format. So data array. So in this case, for example, let's say I have observations, right? So this is a normal regular return from observation. This has a lot of redundant information here. But in here, let's say I only want to remove those redundant information. All I want is an array of the result of the observations. And you can do this result format is data array. As you can see, this is much, much more compact. So every observation become an array, data array. And you read this, and you know how to parse this. So this, you cannot be more compact than this. So again, the design consider the efficiency and the performance. Okay, next one, order by. So this allow you to order your returns. For example, you can order by result, you can order by phenomenon time, you can even order by ID. And you can also order by, you can do the ascending order or the descending order. For example, let's do order by, let's say, result. So it's order by result, right? 0, right? But let's say we want to do the descending order. So order by result, descending. And this is a string that's descending, okay? And then, yeah, this is descending order. Let's say that if we do order by ID, descending, so you can see the ID is the big one, is the first. If we do ascending, The small one is the first. Okay. Sorry for the, we try to cover a lot in a very little amount of time, but yeah, you can always come back to the video and review it. The next one is top. Top allow you to do paging, client-side pagination. So let's say I only want the first top result, so you can use top equal 5, and then you get only the top 5. But when you have a top 5, that means it need to follow some order. So you can decide the order as well. For example, I only want to have the top 5 result ordered by the time with descending order. And this allows you to do that. The next one is skip. So this is a very common client-side paging. So skip allow you to, so let's say you have a return, and then you want to get the top 5. But if you use, like for example, only the skip is number 5, that means you start to get your return from the 6th. If the skip is 10, so you start to get your return from the 11th. So this is a client-side paging. So we combine with top and skip allow you to do paging. So return the subset of the result. Okay. Next one, filter. So filter basically is the query function. So allow you to filter with the query options. So for example, this diagram table shows you some of the logical operators supported by the SensorThings API, allow you to do some filtering. So actually, I'm going to show you some examples. Let's use this thing, I guess. Let's do observation, I guess. Okay. So the first filter I want to show you is you have this $sign filter and equal. Okay, let's say I want to get the result greater than 1,000. Okay, so that means you get your result. You only get the return which has result greater than 1,000. So there are about almost 500,000 results greater than 1,000. How about this then? Something like that. It's less than. Okay. Let's say okay. We have other functions. For example, let's say things. So not only you can have this great. Okay, this is a good one. In this query, it shows you that the filter. So I want to get the things whose description. In this case, the description. If you look at this address bar, that's a query. So description has a substring of office. So let me execute this query. So if you look at the description here, yes, it has a substring of office. So this is the query of substring of. Okay, so we have many other functions, but I just show you a subset of the functions. For example, let's look at observations. Let's say I want to know to get all the observations that are collected in December. And I can do this. So filter equal and month. What? For example, this one. So let's say month of the phenomenon time is 12. Okay, so in this case, you will get all the observations collected in December. Sorry. Let's use hour. Something's wrong. Let me see. Okay. Okay. Voila. Okay. Syntax wrong. So let's say our phenomenon time equal to 12 in this case. So let's look at it. Yes, I get all the observation collected at the 12th hour. The 12th hour. Okay. And if I change it to month, I only get observation collected in December. So as you can see, it's very, very powerful. A lot of query functions allow you to do a lot of analytics. Okay, so next one. Service-driven paging. So sometimes we have too many results. Like for example, observations. We have 800,000 observations. So we don't want to return you to send all 800,000 over the network at one time. So service-driven paging, that means the server define, okay, so every time the maximum number of entities I will send you is certain number. So this is service-driven paging. So as a result, there is a next link, allow you to get the next page of the result. For example, in this case, if you go to the observations here, let's use this one. So this one, we have about almost 80,000. And this next link allow me to get the next page. And in current design, it's of course it's a configurable number. We return 100 results each time. It could be 100 or 1,000. But following this link allow you to get the next 100, the next 100. So as you can see, actually, this is like this: the top 100 and skip 300. So start from the 300 first. Okay, well, almost there. So I found actually we try to cover a lot of materials here. So if you're interested in connect your Arduino to SensorThings API, this is the link, allow you to preview how to do it. Actually, this is very simple. If you follow that tutorial and then copy and paste to your Arduino IDE, and you should be able to connect to the SensorThings API. So we will show you more examples how to connect different sensors to SensorThings API next week. Useful resources with our playground, so feel free to use it, try it, and API documentation. That's a very comprehensive API documentation you can try. So just FYI. Any questions? And see you next week. Okay, so from the Q&A, we have a couple questions, but right now, if any question, feel free to put in the Q&A. Okay, the first question. Is there any provision in the API to register an endpoint to be utilized for pushing event? For example, I might want to be notified about new observation for a specific thing becoming available without having to poll the API on a schedule. Thank you very much, and the answer is yes. We support MQTT, and it allows you to receive notification whenever there are new updates to the entity. For example, exactly like what you mentioned, whenever it's a new thing get inserted into the API, you get notification pushed to you in MQTT. And whenever there's new observation, it get pushed to you. Whenever there's a new observation of a certain data stream, so that's a navigation link, right? So you can see the power of this navigation link. You can even subscribe to certain data stream. So whenever there's new reading, it get pushed to you. And this is we will cover that, the MQTT in a future webinar. And actually in SensorThings API, we have not only this pushing capability, we are developing something called rules engine. So allow you to register a continuous query. For example, you register a query, you want to get notification when there's a new reading whose result is greater than 100. So you only get the notification when it fits into a query criteria. So that's what we have. Okay. The next question. This is all about get operations. Any review of put post operations, for example, thing device event triggering the creation of new observation? Thank you very much. Yes, and we follow REST. It will be covered in future webinar. So how to create, update, delete the entities. And actually we support, for creation, we support post. For update, we support patch, not put. Actually, if we read the REST, what's that? The RFC, if you read the REST standard, well, the update should be patch, and put is override. So in this case, our specs support patch. And if the service support put, and the user need to know very, very clearly, this is override, or this is just to update certain property. And delete, of course, is a HTTP delete. and also support MQTT as well. Hopefully answer your question. Okay, the next one. Are all the capabilities of the REST API you show part of standard, or does SensorUp have some enhancement? Everything we show today is the spec. We do have some enhancement internally, but today whatever we show is the standard compatible one. Yes, that answers your question, yeah? Okay, any more questions? You guys are quiet today. If not, please come back next week. So next week we'll cover how to connect the sensors to the SensorThings API, and it will cover actually one of the previous questions, right? So how to do post, update, and delete. Okay. So if not, thank you very much. And the video will be available on YouTube as well as on our blog. And feel free to try our playground and developer documentation. And if you have any other questions, we'll be very, very happy to hear from you and anything we can help you. Actually, we do got some responses. Like there's a group in Italy want to use SensorThings API to do some citizen sensing to monitor the air quality near a garbage burner or something like that. So if you have any idea, please feel free to contact us. Okay. So thank you very much and wish you have a very nice weekend.